Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers OCR Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on, and more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. This table shows the names and areas of 5 lakes. Well, not heard of many of these. Lagoda, Muero, Tana, Topozero, Victoria. Part A says write the area of Lake Mweru as an ordinary number. So here's Lake Mweru, and you can see that in standard form, you can see its area is 5.12 times 10 to the 3. Okay, so converting that into a normal number, you've got standard form power 3 here, which means I can either multiply it through by a 1 followed by 3 zeros, or I can just shift the decimal point 3 jumps to the right, can't I? So 1, 2, 3. So it's going to be 5, 1, 2 and an extra 0 then on the end. Okay, so that's 5,120. Part B says write the lakes in order of their area, starting with the smallest. Okay, well the one which is the smallest is going to be the one with the lowest power, isn't it? Because that is going to be the smallest magnitude. So this one here with the 2, that is going to be the smallest. So Topo 0 is the smallest. Okay, next power of 10 up is 3. So 10 to the 2 is hundreds, isn't it? And 10 to the 3 is in the thousands. So both of these lakes are have areas in the thousands. Now obviously 3,000 is less than 5,000, so Tana is going to be the next smallest, and then Mweru, because 3.2 is less than 5.12, isn't it? Mweru. Okay, and then I've got 2 lakes whose areas of the magnitude 10 to the 4, which is in tens of thousands of square kilometers, isn't it? So out of Lagoda and Victoria, you can see Lagoda's got 1.81 and Victoria's got 6.89. So Lagoda is the smaller of the 2 and Victoria is the largest. Ladoga next, and then Victoria. Okay. Part C says calculate the difference between the areas of Lake Ladoga and Lake Tana. Give your answer in standard form correct to 2 significant figures. Okay, so difference in mathematics means subtract, isn't it? So we need to take one away from the other. So we are going to be taking the smaller one away from the bigger one, aren't we? So which one is smaller? Ladoga and Tana. Tana is the smallest because it's 10 to the 3, and Ladoga is 10 to the 4. So I'm going to take the smaller one away from the bigger one. So that's going to be 1.81 times 10 to the 4 subtract 3.2 times 10 to the 3. Okay, now It's a bit hard to subtract numbers when you've got these powers, different powers on the end. But if I take a power of 10 out of 10 to the 4, so if I take 10 out of 10 to the 4 and leave it as 10 to the 3, and with that 10 I can multiply the mantissa part of the number and get 18.1 times 10 to the 3. So I've kind of taken a 10 out of the power and stuck it in with the mantissa at the front. Then I've got 18.1 times 10 to the 3 minus 3.2 times 10 to the 3. Now these two are now of the same magnitude, so I can go ahead and I can subtract the mantissa parts from each other. So 18.1 subtract 3.2. Well, 18 take away 3 is 15, and 15.1 take away 0.2 is going to be 14.9, isn't it? So that's equal to 14.9 times 10 to the 3. Okay. Now I'm going to take the 10 back out of the 14 and put it back in with the 10 to the 3. So that's going to be 1.49 times 10 to the 4. Final answer does ask for two significant figures though, so I'm going to round this off and say that is 1.5 times 10 to the 4 as the final answer. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18, and so on. And 9 is 9, 18, 27, and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there, so our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. The diagram shows the results to the nearest percentage of a survey of 1,000 motorists. Driverless cars. Good idea, 20% think it is. Bad idea, 34% think it is. And not sure, 45% think it is. Interestingly, they don't add up to 100%, do they? Right, work out the largest possible number of motorists who thought driverless cars were a good idea. So actually, this is to the nearest percentage. It's a limits of accuracy question, isn't it? So if it was 20% to the nearest percentage, it means it's been rounded off to 20. Now, the next percentage up would be 21, and the next percentage down would be 19. So the ones that round to 20 are the ones that are halfway between those two. So the limits are going to be 19.5 and 20.5. They're the ones that round to 20 to the nearest percentage. So work out the largest possible number of motorists who thought driverless cars were a good idea. The largest possible is going to be the larger of those percentages then, isn't it? So I'm going to be using this upper limit then, 20.5, to calculate. And obviously 20.5 you round up to the next value up, 21, but it still is the boundary and is still the one we calculate with. So largest possible is going to be 1,000 times by 20.5%, which is 1,000 as a multiplier. That's 0.205, isn't it? So that is 205. Now, strictly speaking, if it was 205 exactly, that would round up to 21% and not down to 20%. So I'm going to subtract 1 from that and write my answer as 204, because I know that definitely will round down to 20%. The diagram shows a cuboid and its diagonal, and the formula to work out the length of the diagonal in centimeters is length of diagonal equals the root of a squared plus b squared plus c squared. This is one of those interesting extensions of Pythagoras theorem. So when you move from 2 to 3 dimensions, all you got to do is add in your extra length then to work out the length of the diagonal. Quite cool. So what do we have to do here? Work out the length of the diagonal where a is 8, b is 3, and c is 2. We just need to put those numbers then into the calculation and work it out. So length is equal to the root of a squared, 8 squared, plus b squared, 3 squared, plus c squared, 2 squared. So job for my calculator, root 8 squared plus 3 squared plus 2 squared. That gives me 8.77. Oh, two significant figures, 8.8. Okay, now part B then says work out the length of the diagonal in terms of A when B is 2A and C is 2A. Okay, so we've got to do the same thing algebraically now. So the length is going to be equal to the root of a squared plus b is going to be 2a, so 2a squared, and c is going to be 2a squared, like that. So how many a squares have we got then? I've got a squared plus 4a squared plus 4a squared, which gives me 9a squared, and the square root of 9a squared, well, the square root of 9 is 3, and the square root of a squared is a. So it gives me 3a. And obviously when you square root you often get two results, positive and negative, but in this case there is only one solution that's valid, isn't it? It's 3a. The diagram shows the scale drawing of a sandpit ABCD. It also shows the arc of all points in the sandpit that are 80 centimeters from the corner A. We're told that the scale of 1 centimeter represents 20 centimeters. A game is played by throwing a ball into the sandpit. Points may be scored when the ball lands in the sandpit. 1 point if the ball lands within the 80 centimeters of corner A, and 1 point if the ball is closer to side AB than to side AD, and 1 point if the ball is closer to corner A than it is to corner B. By completing the construction, find and shade the regions where 2 points can be scored. Show all of your construction lines. Right, now the first construction is already done for us, isn't it? So the one where it has to be within 80 centimeters from corner A, that circle has already been drawn. It's that arc, isn't it, there? Yeah, so you can see this one is 4 centimeters, which is 80, so that has already been done. So I'm going to move on to the second one, which says 1 point if the ball is closer to side AB than AD. Okay, so the construction that we need for the points that are equidistant from two lines is the angle bisector of those two lines. Okay, so what we're going to have to do is construct the angle bisector. Now normally I would put the compass at A first and do an arc that cuts both, but we've already got this handy arc already drawn, so I'm just going to use those 2 points to mark my cross in the middle to make the angle bisector. Okay, so that makes my job a little bit easier. So sticking on either end, we're drawing a little arc, and then where they cross, that is going to be where my angle bisector is going to go through. Okay, so the line I'm drawing are all the points that are equidistant away from those two lines. So clearly if I want it to be closer to AB, then I want it to be below that line there then. Right, next construction. The point of if the ball lies closer to A than to B. So the points that are equidistant from two given points A and B are going to be the perpendicular bisector of that line. Okay, so in order to draw a perpendicular bisector, I'm going to set my compass to a little bit over halfway between those 2 points, and I'm going to draw an arc with the compass based at B. Okay, a bit of a semicircle going on there, and then switch over to A, and I'm going to draw another semicircle. We should find that they meet in 2 places. Okay, it's a little bit off screen. Let me just push it up a bit. So drawing a line through where those 2 arcs crossed, that's going to be my perpendicular bisector. So all of those points are equidistant from A and B. Okay, so if we want the points that are closer to A, then I want the points to the left of that line. As I said earlier, if I want the points that are closer to the line AB than the points AD, then I want those below the angle bisector. Okay. Now in this case, I then want the ones outside of the circle then, because if it's inside the circle, it'll be worth 3 points. But I want to highlight the ones that are just worth 2 points. So inside the circle would meet all 3 conditions, and then they'd be worth 3 points. Now, is there any other place which is worth 2 points? This one here is, isn't it? Because that's inside the circle and closer to A than to B, so that's worth 2 points. What other regions have we got? This one up here is only worth one point because it's closer to A than B, but doesn't meet any of the other conditions. And that one down there is worth 1 because it's closer to AB than AD, and the one at the top is worth 0 because it doesn't meet any of the conditions. Right, so they're the 2 regions that I want, and I've shaded both, so that's job done. Let's move on. Question 11. Joe and Kyle share an amount of money in the ratio 7 to n. Joe gets 35% of the money. Work out the value of n. Okay, so we know that Joe to Kyle is in the ratio of 7 to n. Now, Joe gets 35% of the money. So what percentage would be left then for Kyle? Kyle's going to get the rest then, isn't he? So if I've got 100% and I let Joe have 35% of it, then Kyle is going to get 65% of it. Okay? Can you see that that is, well, the relationship between these two numbers, that's 5 times bigger, isn't it? Okay? So then n, if I multiply n by 5, I'm going to get 65. In other words, n then must be 65 divided by 5. 65 divided by 5 is 13, so n is 13. Question 11, use trigonometry to work out the size of angle x. Okay, right, so trigonometry is a right angled triangle, so it's about soccer, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want x. So the ratio that includes the adjacent and the hypotenuse is that one there. Cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which I'm just going to round off to 1 decimal place, 25.8. Diagram shows a triangular prism and a cube. The ends of the prism are right angled triangles with base 6 centimeters and height 12 centimeters. The prism is 18 centimeters long. The volume of the prism is equal to the volume of the cube. Find the surface area of the cube. You must show your work in. Okay. Right, so we've got volumes of prisms here, and the volume of any prism is going to be a cross-sectional area times its height or its length, isn't it? Okay, it's the distance between their front and back face. Times height or length. Okay, it's the distance between their front and their back face. Okay, right, so our original prism, the volume of the triangular prism, what's that one then? Okay, what is the cross-sectional area? What's this area here? Okay, well, it's a triangle, so its cross-sectional area is going to have formula half base height, and then we're going to multiply it by the length between the front and the back face, then, aren't we? Okay, so that's half times the length of the base. The length of the base is 16, so base is 16. The height of my triangle is 12, so that's going to go there, times 12. And then the length of my prism is that 18 there, so that's going to go on the end. Okay, so I've got half times 16 times 12 times 18. Okay, so what's that then? 0.5 times 16 times 12 times 18. That comes out to be 1,728. Okay, right, so 1,728. So that must be the same then as the volume of the cube. That's 1,728 in there then. Okay, so then what is the length of this cube? Okay, so then cube length, it's just going to be the cube root of that number then, isn't it? If they share the same volume, I normally get the volume of a cube by multiplying the length by itself 3 times. So if I cube root that number, it should give me the length of the cube. So what is the cube root of 1728? That comes out to be 12 apparently. So this is going to have a length of 12. So then what's the surface area of a cube? Well, a cube is made up of 6 separate square faces, and each of those faces has an area of length times length. So it's going to be 12 times 12 then, isn't it? So the surface area is going to be 6 faces times the area of each face, 12 times 12. What's that then? So 6 times 12 times 12, that comes to be 864. So the surface area of this cube is going to be 864 square centimeters. Describe fully the single transformation that maps triangle A onto triangle B. Now A and B are different sizes, so it's definitely going to be an enlargement of some sort. Now notice that A is the larger one and B is the smaller one, and we want to find a transformation that maps the larger one onto the smaller one. So it's going to be an enlargement with a fractional scale factor. So we need to know what that scale factor is, and we also want to know where the centre of enlargement is. Now to find the scale factor, we just need to find 2 sides that are the same and compare them. So let's have a look at that side compared to that one. This side is of length 3, this side is of length 1. So my triangle B is 1/3 of the original height, or the original length. So the scale factor is going to be 1/3. The next thing we need to know is the centre of enlargement. Now the easiest way to find that is to draw on some ray lines that pass through matching corners of your shape. So let's draw one between those 2 points. And let's draw one through those 2 points as well. You can see that these ray lines are converging on the origin. I could draw a 3rd one in as well, but actually I've already seen what the answer is. So they're all converging on this point here. So that's the centre of enlargement. So to fully describe the transformation, I'm going to say that this is an enlargement with scale factor 1/3 and centre origin. The straight line passes through the point 8, 1 and is perpendicular to the line y equals 4x minus 2. Find the equation of the line given your answer in the form of y equals mx plus c. Okay, so from the line y equals 4x minus 2, then our gradient, which I'm going to call m1, is 4 then, isn't it? Okay, so our line is perpendicular. In other words, m2, our gradient, is going to be minus 1 over m1, the negative reciprocal of the original gradient, so that's going to be minus 1/4. Okay, so I've got the gradient already of my new line. All I need to do now is to find c, the intercept, don't I? Okay, and to do that, I'm going to use this point up here that it passes through. Okay, so first off, I'm going to say equation is of form y equals minus 1/4 of x plus c. So I've kind of created a partial equation by subbing in the m value I know of minus 1/4 here, and that just leaves me the c value to find. And I'm going to use the point to find it now. So line passes through the point 8, 1. So subbing those values into the line, that means this is 8 is the x value and y is the 1 is the y value. So subbing in the y equals 1, and that is equal to minus a quarter lot of x, which is 8 plus c. And then what's that then? So minus a quarter lots of 8, that's minus 2. So I've got 1 equals minus 2 plus c. Adding 2 to both sides, you can see that c is equal to 3 then, isn't it? Okay. So now I've got the full equation. Therefore, equation is y equals a minus a quarter of x plus 3. The amount spent on clothes by 40 boys and 40 girls in 1 month was recorded. The table shows information about the amount spent by the boys. Okay, and I can already tell from the table, this is a group frequency table. So again, group frequency, they've got the midpoint marked, so I'm guessing they're going to ask me to find that estimated mean. The mean for the girls was £35. Estimate the mean for the girls as a percentage of the mean for the boys. Okay, so obviously the first thing I need to do is find what the mean for the boys is. So as I said, the table is already set up for it. To find the mean from a group frequency table, or estimate the mean, the first thing you've got to do is work out the midpoints of each of the groups or classes. That's because you don't know, out of these, for instance, these 22 boys here, you know that they scored between 0 and 20, but you don't know the precise value, do you, of what they got now, because the data's been grouped. So we use 10 halfway between them. 0 plus 20 divided by 2 is 10, as an estimate of what those 22 boys spent. Okay, so going down the list and working out the other endpoints, the midpoints. So 20 plus 40 is 60, divided by 2 is 30. 40 plus 60 is 100, divided by 2 is 50. And 60 plus 80 is 140, divided by 2 is 70. Okay, so they're the midpoints that I'm going to be using. So if I'm saying that 22 boys spent, well, I'm estimating £10 each, then between them, if I multiply those together, 22 times 10 is 220. Okay, I'm going to do that for each of my other values. 30 times 9, was that 270? 50 times 6 is 300, and 70 times 3 is, what's that, 210? Okay, adding that up, you can use your calculator if you like, but often it's easier just to do it in your head. So that's 0, and then 2, 7 and 1 is 0, carry 1, and I've got 2, 4, 7, 8, 9, 10, so that adds up to 1,000. Okay. You might want to double check it on your calculator, but I think that's right. So then the estimated mean then for the boys is going to be sigma fx which is this amount here, isn't it? The sum of the frequencies times their values, which is 1,000. Divided by sigma f, which is this value here, the total sum of the frequencies. So 1,000 divided by 40. So what's that? I think it's 25, but let me just double check. 1,000 divided by 40, 25, yeah. Okay, so the estimated mean for the boys is 25. The mean for the girls was 35. Estimate the mean for the girls as a percentage of the mean for the boys. So if you're expressing one number as a percentage of the other, then the number that you are talking about first is the top number, and the number you're talking about second is the bottom number. So then the percentage, it doesn't look quite right here because it's a big one on the top, is going to be the mean for the girls, which is 35, divided by the mean for the boys, which is 25, and they're going to have to turn that into a percentage. Okay, so what's that then? So 35 divided by 25, That gives me 1.4, and times 100 is 140%. Okay, so the mean of the girls as a percentage of the mean of the boys is 140%. Oops, 140. Danny has a pack of 45 cards. Each card is either red or black. 1/3 of the cards in the pack are red. She picks 2 cards from the pack without replacement. Calculate the probability that Danny picks 2 black cards. Okay, so this is a probability, well, it's a dependent probability question, isn't it? Where we have 2 selections and the outcome of the second selection is dependent on the first. We know this because of the word without replacement. When you don't replace the object you select and you make a second selection, you're going to have a different number of things to select from, and you're going to have different amounts of each depending on your first selection. So it's definitely a dependent probability question. Now the best way to demonstrate this is using a tree diagram. Okay, so either we get red or we get, I can either use black. I'm just going to tend to use not red. So red and not red, red and not red for our second selection, red and not red for my second selection. Okay, so what are the probabilities here? So if 1/3 of the cards in the pack are red, that's going to be 15 out of 45 then, isn't it? 15 out of 45 are going to be red. So red 15, and not red or black, there are going to be 30 then, aren't there? Okay. So what's the probability of selecting a red card on the first draw? Well, you've got the 15 red cards and you've got a total of 45 cards. So the probability of not red or black is going to be 30 not red cards out of a total of 45 cards. Okay, so that's the first selection. Now the second selection, this bit up here is going to be different from this bit down here, isn't it? Because if I go up that first branch, it means I've already selected 1 red card. So I've got one less red card to pick from on the second selection. So the probability of getting a red second time around is going to be 1 less red card out of 1 less card, which is 44. Now, if what's the probability of getting not red? Well, I've still got 30 not red cards in the draw, but I've still got 44 because I've already picked one. Okay. Now, if I go down the not red branch, that means I've already picked 1 black card out, which means there are still 15 red cards to select out of a total of 44 cards. And how many not red ones? Well, if I picked a not red one the first time, then I've got 29 remaining out of 44 to pick on the second selection. Okay, right, so we want to work out the probability that Danny picks 2 black cards, which is the not red route then, isn't it? It's that route down there. So the probability of not red is 30 over 45 multiplied by 29 out of 44. Okay, what's that? So 30 out of 45 times 29 out of 44. I believe that comes to 29 out of 66. 29 out of 66, apparently. Okay, I think we're done. We've got x plus 2 times 3x plus a times bx plus 3, and that's equal to 6x cubed plus 11x squared minus 17x minus 30. And we need to find the values of a and the values of b. Okay, now I think what we're going to do here, we've got triple brackets, which I'm going to try and multiply out as best I can and then compare them with the other side to see if I can work out what the values of a and b are, using a technique called comparing coefficients. So I'm just going to start with one side. So I'm going to start with the left-hand side of this. I don't want to deal with everything all at once. So I'm just going to start with the left-hand side. So I've got x plus 2 times 3 times 3x plus a times bx plus 3. So I'm just going to ignore the last bracket and just kind of do FOIL on the first 2 brackets. So just multiplying that with that, that with that, that with that. So what I get is x times 3x, which is 3x squared, and then x times a, which is ax, and then 2 times 3x, which is 6x, and then 2 times a, which is 2a. Okay, so that's what I get when I multiply out those two terms. Okay, and then I need to carry on multiplying it out. Now I need to multiply everything in the first bracket with everything in the second bracket. Okay, so I'm going to start off by multiplying everything through by bx and writing it down first. So 3x squared times bx, that is 3bx cubed. And then I've got ax times bx, which is abx squared. And then I've got 6x times bx, that's going to be 6bx. And then I've got 2a times bx, which is 2abx. Okay, so I've multiplied everything in the first bracket by bx, and now I'm going to multiply everything in the first bracket by 3. Rather than writing a big long line, I'm just going to drop down the line, and I'm going to start doing it from here. So I kind of, you'll see why I'm doing it that in a sec. So 3 times 3x squared, that is 9x squared. And then I've got 3 times ax, that is 3ax. And then I've got 3 times 6x, which is 18x. And I've got 3 times 2a, which is 6a. Okay? Right, so now we need to kind of combine all those together. So you can see I've got terms in x, I've got terms in x squared, I've got terms in x, which is here, 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 and here, and then I've got a term in, well, a number on the end, which is our constant on the end. Now what I want to do is I want to compare that to this thing up here that we wrote and that we had up here. So that is all equal to 6x cubed plus 11x squared plus, right, all 4 of these are going to be, oh sorry, minus. It's going to come to minus 17x, and then I've got minus 30 on the end. Okay, so if you think about it, that's that it's 3bx cubed matches up with this 6x cubed. So comparing coefficients, we call it. Compare coefficients of, first off, x cubed. What's that going to give us? So the x cubed coefficients, I've got 3b on one and I've got 6 on the other. So if these two expressions are equal, then they've got to be equal as well, haven't they? So 3b has got to be equal to 6, which tells me that b is equal to 2. Okay. Now I could look at the second one, but that hasn't got any a's in it, so that's no good. So I'm just going to have a look at this one on the end. So I've got 6a, and that matches up with 30 down here, or minus 30 actually. So comparing the constants, we've got 6a is equal to minus 30. Okay, right, so that gives me a is equal to negative 5. So a was negative 5 and b was 2. Okay, now a lot of this work here was superfluous. In fact, all of this bit in the middle, look, all this bit in here I didn't actually use or need. Okay, so actually you could have just shortcut this by just thinking about what term delivers you the x cubed term, and just kind of thought, well, that times that times that is going to give me my x cubed term, and that's going to be equal to 6. And what term delivers me the constant at the end? Well, it's that term times that term times that term. So you could have done it that way and saved yourself a bit of work. I've kind of done it long. It's only worth 2 marks, but hopefully you can see why it is what it is and decide whether or not you want to kind of do a full method or just kind of focus in on the x cubed term or the constant term and kind of do it a bit faster. Sophia is competing in a long jump competition. Her first jump is 5.25 meters. Her best jump is 8% more than this. However, her best jump is 10% lower than the winning jump. Work out the length of the winning jump. So let's just try and visualize that. I've got a 5.25 was her first jump. Her best jump was 8% above that. But as good as that one was, it was 10% less than the winning jump. So that was her best, and this was the winner. Okay, so let's work out her best jump first off. So best is going to be, well, it's a percentage increase, isn't it? So using our triangle final original multiplier, our final is what we're trying to get. Our original is 5.25 and our multiplier is, well, it's 100% plus 8%, which is 108%, which is 1.08 as a multiplier. So our final is equal to our original times our multiplier. In this case, the original was 5.25 times a multiplier of 1.08, and that gives me 5.25 times 1.08 gives me 5.67. So 5.67 is a very best jump. Okay, but the winning jump, well, this 5.67 is 10% lower than the original amount. So the winning amount is, well, the winning amount subtract 10% is 5.67. So I actually want to do a reverse percentage here. So for the winning one, our final is 5.67. It's her best one. Our original is what we're trying to find, and the multiplier is going to be 100% less 10%, which is 90%, which is 0.90 as a multiplier. So using again the triangle final original multiplier, this time we are looking for the original, and we're going to use final divided by multiplier to find it. So that is 5.67 divided by 0.90, which is 6.3 meters, so 6 meters and 30 centimeters. That's a long jump. She's nowhere near it. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Okay. Now, the most popular way for this to be taught, I believe, is looking at second differences and using a kind of a convoluted way of piecing those two together. So the second differences here, for instance, are going to be 11, 21 take away 38 is 17, 38 taken away from 61, that is 23, and 61 taken away from 90, that is 29. Okay, and then so that's what we call the first differences. The second differences are the differences of the differences. So you can see that's 6, 6, and 6. Okay, so normally when people are taught how to do this, they're taught to find the second difference, take that value of 6 and halve it, and then that is going to give you your n term, 3n squared. And then you have to work out the rest. You have to kind of then work that out and take it away and all that sort of palaver. But actually there's a different way that you can do it that I want to show you. Well, maybe let's just finish this method off first, and then I'll show the alternative way of doing it, which I think is nicer. So 3n squared. So if n is, remember this is when n is 1, n is 2, n is 3, n is 4, n is 5. Okay, so this sequence, if n is 1, 3n squared would be 1 squared times 3. It should be 3. When n is 2, 2 squared is 4 times 3 is 12. When n is 3, 3 squared is 9 times 3 is 27. And then 4, n squared is 16 times 3, 32, 48. And then 5 is 25 times 3 is 75. So then you work out the differences between your original sequence and this sequence for 3n squared. So what's that then? So the difference is 10 take away 3 is 7, 21 take away 12 is 9, 38 take away 27 is 11, 61 take away 48 is 13, and 9 take away 75, that is 15. Okay, so now what we've got left with, I hope you can see, is a linear sequence. So this has got a common difference this time. It goes up in twos, 2, 2, 2, 2, which means it's got to do with 2n. Okay, but it's not quite 2n, is it? Because 2n would be 2, 4, 6, 8, 10, and we've got 7, 9, 11, 13, 15. And that is 5 more than 2n. Okay, so then we combine these 3 bits together to work out that the nth term then of this quadratic, therefore nth term is 3n squared plus 2n plus 5. Okay, so now the reason I'm not so fond of this method is that, you know, why 3n squared minus, do you even know why you have to halve it there? It's just kind of learning a way of doing something. You don't really understand why it is what it is. Okay, well, that's the reason why I don't particularly like it. So we're basically teaching students how to do something. We're not teaching them why. When we're teaching this method, they rarely understand why you have to take the 6n, the common difference, and halve it, and that gives you 3n squared. They don't really make the connection. So I tend to teach it a different way. I use it with the general forms of a quadratic. So if it's a quadratic sequence, then the general form of a quadratic is an squared plus bn plus c, isn't it? That's the general form of the quadratic, okay? Where a, b, and c are some constants, okay? Now, when n is 1, that's the first term of our sequence, isn't it? So when n is 1, then an squared plus bn plus c, I'm going to have 1 squared times a, that's a, plus 1 lot of b, which is b plus c, okay? And I know that that is equal to the first term of my sequence. It's actually equal to 10. Okay, now when n is 2, then an squared plus bn plus c, an squared, take n, 2, and square it, 4. I'm going to get 4a plus bn, which is 2b plus c. That is equal to my second term. That is equal to 21. Okay, and then when n is 3, n squared is 9, so that would be 9a plus 3b plus c, and that is equal to our third term, which is 38. So what we do instead with this, we kind of, and that's, you just kind of stop there. What we're doing is we're forming 3 simultaneous equations in a, b, and c, which we can then go on and solve simultaneously. Okay, now you might think, oh, simultaneous equations is horrid. Why on earth would we do it this way? This is really complicated. But actually, this bit here is the same no matter what sequence, quadratic sequence you're given. You always get this. So the only thing that you have to do is kind of bolt on your extra terms that you've been given from the actual sequence to form your equations. And then the technique becomes very similar. So after you've done a few this way, it comes really, really easy. Okay, so I've got 3 equations in 3 unknowns, a, b, and c, which I'm going to go on and solve. So the first thing I'm going to do is going to take equation 2, and I'm going to subtract equation 1. So equation 2, this one, subtract equation 1, which is this one. So what's 4a plus 2b plus c if I take away a plus b plus c? So kind of taking those away, I'm going to get 3a plus b, and the c's are going to cancel, so I'm going to get 3a plus b and that is going to be equal to 21 take away 10, and 21 take away 10 is 11. Okay, and then I'm going to do the same thing. I'm going to do equation 3 take away equation 2. So then I've got equation 3 is this one, equation 2 is the yellow one. So taking the blue one, yellow one away from the blue one, so then 9a take away 4a is 5a, and 3b take away b is b, and 38 take away 21 is 17. Okay, so now I'm left now with 2 equations in 2 unknowns. Okay, so that's my second step. And now what we're going to do is we're going to take one of those away from the other. So that's going to be in my equation 4 and my equation 5. And now I'm just going to take 4 away from 5. So equation 5 take away equation 4. What's that then? So equation 5 then is this one. Equation 4 is this one. So if I'm taking equation 5 and I'm subtracting equation 4, what do I get? That's going to give me 2a is equal to 6. So a is 3. Once I know a, I can then sub it back into one of either 4 or 5 here. So 3a plus b is equal to 11. So 3 lots of 3 is 9. 9 plus what is 11? That tells me b is 2. Okay, and once I know b, then I can sub all those back into the first equation. A plus b plus c is 10. So a plus b is 5, and then what do I have to add on it to get 10? It must be 5, so c is 5. Okay, so they're my solutions. A is 3, b is 2, and c is 5. Then going back to our original form, a squared plus b, an squared plus bn plus c, just got to sub those values in. Therefore, nth term is equal to 3n squared plus 2n plus 5. Okay, so this draws on your knowledge of solving simultaneous equations. You might think, "Ugh, that looks hideous, I don't want to do it that way," but I would recommend giving it a go, because it's always the same. When you're doing this, no matter what quadratic you're doing, you'll find that 90% of the method is the same for every question, and you just get quite good at doing it. Okay, so try it. I'm not saying you have to do it this way, but I'm saying I think it's a better method, and students who do learn it this way tend to do quite well at it. So yeah, give it a go or not. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now, notice that this 8 here and this 8 here are the same. So the number of shares for girls is the same. And the boys has gone from 6 to 5. So it's reduced by 1. So overall, we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we will find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. The point -5, 2 lies on the circumference of a circle, center OO. Find the equation of the circle. Okay, I'm going to quickly draw this. I'm not excellent at drawing circles freehand, but no, that was quite appalling. Let's try that again. Okay, that one isn't too bad. And then I'm going to draw some axes. Now the center of this circle is at the origin, so my axis is going to pass through the center point of my circle. Like that. Okay, so my origin there is the point 0, 0. It's the center of the circle. And I know that at the point -5, 2 lies on the circumference of the circle. So -5, 2 is going to be kind of over there somewhere, isn't it? Okay, that's going to be -5, 2. Okay, so I want to find the equation of the circle. Now the equation of any circle centered on the origin is going to be of the form x squared plus y squared equals r squared, where r is the radius of the circle. Now we can find the radius of this circle by finding this length here then, can't we? So if I find how long this line is here, that's going to be the radius, isn't it? Okay, and we can do that by just using the coordinates of that point. So we can then use Pythagoras theorem to find the length of the hypotenuse there. So this length, this triangle here, is going to be 5 by 2 then, isn't it? Okay, so using Pythagoras theorem, I can say that r squared, which is the hypotenuse, is going to be equal to 5 squared plus 2 squared. 5 squared is 25, 2 squared is 4. Add them together is going to give you 29. So r is going to be the root of 29 then, isn't it? Okay, so if r is root 29, or r squared is 29, then I can say therefore the equation of this circle is going to be x squared plus y squared equals r squared, where r squared is 29. So that is the equation of this circle. It's just as simple as that. Find the radius, stick it in that equation, job done. Part B says work out the gradient of the tangent to the circle at -5, 2. Okay, so a tangent to the circle is a line just touching the circle at that point. So the gradient at -5, 2 would be this line here, wouldn't it? Okay, let's pick another color. I choose U, purple. Okay, oh no, didn't draw. Let's try that again. Okay, now drawing a sketch of your there's no drawings here, but quickly drawing a sketch is useful because it tells me information. It tells me that the gradient I'm looking for is negative because it's sloping down, and it's also going to be quite a large number, isn't it? It's going to be like -3, 4, something like that. Okay, so it tells me information which I can use to check my answer to see if it's sensible. Okay, now how am I going to find the gradient of that line? Well, we know that the tangent of a circle is always at right angles to the radius drawn at the point of contact. So I know that if this was the gradient, this was m2, then I know that it would be a -1 over m1, wouldn't I? I know that because m1 times m2 is always -1 for perpendicular lines, isn't it? Okay. Remember I said this was a shortcut for writing parallel. You can also write perpendicular like that as a kind of a right angle with AR written on the end. So for perpendicular lines, m1, m2 is -1. So if I can find the gradient of my radius, then I can use that to find the gradient of the tangent then, can't I? Okay, so let's do that first then. Gradient of radius is going to be, well, it's going to be change in y divided by change in x, isn't it? So change in y is 2. and changing x is 5. So that's going to be 2/5. So gradient of tangent m2 is going to be minus 1 over m1, isn't it? Okay, so it's the negative reciprocal. So take my 2/5, flip it over, stick a minus sign in front of it. It's minus 5 over 2. Okay. Now, I did say at the beginning that it's useful to have a sketch, tells you extra information. I said that my gradient is going to be negative. It's going to be like 3 or 4. I've done it now, and it came out to be minus, well, 5 divided by 2 is minus 3.5, isn't it? So yeah, I mean, it told me a lot of things, and I can be confident now that my answer is probably correct. Now, if I hadn't drawn that sketch, I wouldn't be anywhere near as confident that I had the right answer. So always good to draw a sketch in a shape and space graphy question if you haven't got one. Show the equation x to the power 4 minus x squared minus 9 is equal to 0 has solutions between x equals 1 and x is equal to 2. Okay, and I'm going to do this by creating a table. And now I've already spotted what part B is. It says find the solution correct to 1 decimal place. So I'm going to take various values of x, and I'm going to test what their values are by sticking them into this equation. And I'm going to check which side of 0 they lie, whether or not they're positive or negative. If they're negative, if one's negative and one's positive, it means that the solution must lie somewhere between the two. Okay? So I'm going to make a bit of a table, and I'm going to put subsequent values in. Now for part A, I need to test what 1 is, and I need to test what 2 is. But for part B, I'm going to test some more values. So I've made this table bigger than just those two values. And actually, I'm just going to do this all on the calculator anyway. So I'm going to go into menu mode, and I'm going to select table mode. Okay, this makes this super easy. So let's go into table mode. Now you get f of x is equal to, I'm going to type in the formula that I've been given, x to the power 4 minus x squared minus 9. So x should be, where is x? It's up there. X to the power of 4 plus, sorry, minus x squared minus 9. Okay, so that's my function, x to the power 4 minus x squared minus 9. It's going to ask me for g of x. This calculator mode can handle 2 functions at once, but we don't need a second function, we just need one. So I'm just going to press equals again, it's going to skip over there. Right, now my table range, it's asking my start and end value now. So this is going to be my start value, 1, and this is going to be my end value, 2. So I want it to go between 1 and 2. Now the step is how many divisions you want between 1 and 2. Now I'm going to need more information a bit later on, but for now I just need to go up in step of 1 because I only want the start point and the end points of 1 and 2. Now if I press equals now, I'm going to get a table, and you can see on the left I've got the x values 1 and 2, and on the right I've got the values I'm going to get if I put those values into that function x to the power 4 minus x squared minus 9. So I'm going to get, if x is 1, I'm going to get minus 9, and if x is 2, I'm going to get 3. So minus 9 and 3 go in my table. Okay, so when 1 went in, it's negative, and when 2 went in, it was positive, which means that there must, therefore, must be a solution between 1 and 2. Okay, because 1 is on one side of 0 and the other one is on the other side of 0, there must be a solution somewhere in between. Okay, now in the second part of the question, it wants you to find this correct to 1 dp. Okay, I'm going to press the AC button again, and then I'm going to keep the function the same. I still don't have a g of x value. The start and end value is still going to be 1 and 2, but I'm going to change the step this time to 0.1 because I want to see all the solutions between 1 and 2. Now if I press equals again, I'm going to get a bigger table now. You can see I've got values for x for 1, 1.1, 1.2, 1.3, all the way down to 2, going up in increments of 0.1 along the way. Now what you're looking for is the change in sign. Okay, where does it go from negative to positive? So you can see for 1.1, 1.2, all the way up to 1.8, they're all negative, and then 1.9 is positive. Okay, so that means that a solution to this must lie actually between 1.8 and 1.9. Okay, so we already knew it would lie between 1 and 2, and we've kind of narrowed that down a bit now. So now we know that the solution must be between 1.8 and 1.9. So I'm just going to write those two numbers down as well as kind of method for our work here. Okay, so that one is negative and that one is positive. So we know our solution must be between 1.8 and 1.9. Now we need to give this answer correct to 1 decimal place. So that means one of those two answers is going to be our answer. You know, it's going to be somewhere in between, but we're rounding off. So it's whether or not we round down to 1.8 or we round up to 1.9 and give 1.8 or 1.9 as our answer. Now the way to do that is to test the midpoint of those two values. We really need to know what 1.85 is, halfway between. Now if 1.85 is negative, it means my solution must be nearer to 1.9. If 1.85 is positive, it means my solution must be closer to 1.8. So again, I'm just going to press AC. I'm going to press equals, equals to get back to where I can put the step, and I'm going to change the step this time. I'm going to start at 1.8 and I'm going to go up to 1.9, and this time I'm going to go up in steps of 0.05. Okay, so that's going to give me 1.8, 1.85 and 1.9. This is only really the 1.85 value I wanted to write down. So I'm going to write down minus 0.708. Okay, for my minus 1.85 value. Okay, now that is negative again, and that means then the solution must be between 1.85 and 1.9. Okay, because 1.9 was positive, so that means my solution has got to be between 1.85 and 1.9, and all the numbers between 1.85 and 1.9 round off to 1.9 to one significant figure, or one to decimal place, sorry. So the solution to 1 dp must be that one there, 1.9. Okay, now to answer this question and get all the marks, you need to approach it in this way. Okay, you must pin your answer down first between two whole numbers. Then you need to go further and pin it down between two numbers to one decimal place. Then you have to test the midpoint of those two numbers to decide which of the two is going to be your final answer that you give. Okay, very, very particular. The marks are awarded in this way. Okay, so you have to do all those steps. Okay, if you don't test 1.85, you're going to lose a mark. Okay, so you must test the midpoint of 1.8 and 1.9 to decide which of your final two answers you are going to give. Okay, lovely job. Let's move on. Lucy makes 5-digit number cards using all of these cards: 3, 4, 6, 7 and 9. So how many different numbers greater than 50,000 can she make? Okay, so let's consider her choices. If she's going to make numbers bigger than 50,000, then there's a restriction on her first selection of her first digit card. She can only pick one of these 3 to start off with then. So she's got 3 choices for her first selection. For her second selection, doesn't matter which one of those 6, 7 or 9 she picks, she'll have 4 other choices for her next digit number. Then she'll have 3 choices for her next digit, and 2 and then 1. So the total number of selections that she's got is going to be 3 times 4 times 3 times 2 times 1, which is 72 choices. In triangle JKL, M is the midpoint of JK, J to n, Jn to nl is in the ratio of 3 to 2, and we're told that the vector kl is 7a and the vector n to l is 4b. Okay, work out the vector j to m in terms of a, b, give your answer in its simplest form. So what we need to do is we need to find this vector here then, isn't it? Okay, we need to find that one. What do we know? We only know this direction here and we know this direction here. So basically what we're going to have to do is to find j to k and then halve it to find j to m. Okay, I think that's what we're going to have to do. Now we've got some information up here that isn't in the diagram. First off, we've got that m is the midpoint of jk. So that means that this distance is the same as this one then, isn't it? Okay, so let's just mark that on. And we're also told that Jn to nl is in the ratio of 3 to 2. So Jn to nl, so this is 3 to 2 along here. Okay, so if this is in the ratio of 3 to 2 and nl is 4b, then if I divide that by 2 and times it by 3, it should tell me that j to n then, this part down here, is going to be 4b divided by 2 times by 3. It's going to be 6b, isn't it? That's going to be 6b. I'm just going to write that down. That if I've got, if n to l is 4b, and I know that j to n is 3/2 of 4b, then I know that j to n is 6b. And that tells me also that j to l is going to be j to n plus n to l, which is going to be 6b plus 4b, which is 10b. Okay, so I know j to l is 10b. I already know k to l is 7a. So then I can find an expression for j to k, so this distance all the way along here, well, going the other way actually. So what is the vector jk then? Going along places that I know. I can't go direct because I don't know anything about that line yet, but I know the other route. So I know that I can get from j to k by going from j to l and then going from l to k. Okay, and I know that j to l is 10b because I just found it, and I know that l to k is going to be minus 7a. Okay, because I'm going against the arrow, aren't I? So it's negative. Okay, so j to k is 10b minus 7a. Now what we want to know is what jm is, and we know that jm is the midpoint of jk, so j to m is going to be half of the vector j to k then, isn't it? Okay, so that is going to be half of 10b minus 7a, which is going to be, just multiplying that out, I'm going to get 5b minus 7 over 2a, like, just going to write it like that, 7 over 2a, it's like 3.5a. So the vector I want, j to m, is 5b minus 7 over 2a. So we get to finish off the paper with a 5-mark algebraic fractions question. What joy. Okay, so we've got a complex looking pair of fractions multiplied together, and we need to show that it simplifies to a slightly nicer looking algebraic fraction. Okay, so we know about how to combine two fractions together normally. If I have a much simpler fraction like a over b times c over d, we would just say that, wouldn't we? We would say ac is equal to bd. We just multiply the top with top, bottom with bottom, and then we'd see if we can cancel anything out. That's exactly what we're going to do here. We're going to put all of this over into one fraction and then see if we can cancel anything. Okay, so let's start with 2w plus 4 over w squared minus 25 times w plus 5 over w squared plus 3w plus 2. and that's going to equal to something all over 1 divisor. So 2w plus 4 times w plus 5 over w squared minus 25 times w squared plus 3w plus 2. Now, can we cancel anything here? Just having a look at what's on the bottom of this, I've got we've got 2 quadratics on the bottom. Now the one on the left, this one here, is actually the difference of 2 squares, w squared minus 25. If you remember your identities, then a plus b times a minus b is equal to a squared minus b squared, which is what we've got going on here. So that part there becomes w plus 5, w minus 5. The other side of it, this bit here, is a quadratic. Can we factorize it? So does it factorize into 2 brackets? Well, if it did, it'd have a w and a w there. I have 2 numbers that multiply together to give me 2 and add to 3. So w plus 2, w plus 1. And that is over w plus 5 that we can't do anything with, and 2w plus 4 which we can do something with. So this part here, look. So that bit was that bit there. That bit was that bit there. That bit stayed the same, and the 2w plus 4 can become, or we can factorize 2 out of that, and it becomes 2w plus 2. Okay, so that's the blue bit. So we've kind of gone through and we've done little bits to each of those expressions. So now what? Can we cancel anything top and bottom? So I've got a w plus 2 there, which I can cancel with that w plus 2. And I've got a w plus 5 there that cancels with that w plus 5. So they all disappear. So that leaves me with 2 over w minus 5 w plus 1. Okay? So what we've done so far is we've multiplied these 2 things together. Now we still need to multiply that expression with this other bit on the end here, that bit. So that's the bit we're going to do next. So 2 over w minus 5 w plus 1 times 3w squared minus 16w plus 5. What's that equal to then? Well, that is 2 lots of 3w squared minus 16w plus 5 all over w minus 5 w plus 1. Now, it would be very handy if that top quadratic 3w squared minus 16w plus 5 would factorize, and I can then cancel it out with another one of my factors on the bottom. So does that break up into 2 brackets? Well, if it does, it's going to have a 3w here and a w there, and the numbers are going to have to multiply to 5 and add to minus 16. So if we put a minus 5 in there and a minus 1 in there, then that kind of works, doesn't it? So 3w times the minus 5 would give me minus 15w, and the minus 1 times the w would give me minus w, give me minus 16w altogether. So that does work. Right, so then can we cancel anything now? Again, I've got a w minus 5 there and a w minus 5 there, so they can cancel each other out. And I'm left with, what's left? We've got a 2, we've got a 3w minus 1 over w plus 1. Now, is that of the right form? Let's have a look back. Show that it simplifies to aw plus b, cw plus d. We're almost there. I think what it wants then, to make it into that form, I just need to multiply out the top part. Seems a bit counterintuitive, but let's do it. 6w minus 2 divided by w plus 1. Now that seems to be in the form required. The cumulative frequency diagram shows the times taken by runners to complete a half marathon. So underneath, so we've got the cumulative frequency curve, and underneath it asks us to draw a histogram to represent the data and use this table to help us. So I think we need to go through and read off the values first. Then we can populate the cumulative frequency table, and then we can fill out the table we then need for the histogram. Okay, so coming back to the diagram. So time under 100 is going to be this point here. So that's 8. Time under 120 is this point here, which I read to be 56. Time under 160 is up here, that's 100. Time under 200 up there, that's 110. Time under 300, that's the last dot on the top, and that's at 120. Okay, so then we can then work out the frequencies from our cumulative frequency. So between 80 and 100 must be all of those 8, so that goes in there. Between 100 and 120, that's going to be the difference between these two numbers. So 56 subtract 8 is 48. So between 120 and 160 is going to be the difference between 156, which is 44. Between 160 and 200 is going to be the difference between 100 and 110, which is 10. And then finally between 200 and 300 is going to be the difference between those last two numbers, which is also 10. Okay, might want to just double check that those numbers add up to 120, 10, 20, 64, 104, 112, 120. Yes, they do. Okay, so the class width is the difference between these two numbers. So 100 take away 80 is 20, 120 take away 100 is 20, 120 to 160 is 40, 160 to 200 is 40, and 200 to 300 is 100. And frequency density I get by, for it, taking frequency density is equal to frequency divided by class width. So basically I have to divide my first column by my second one, and that would be my frequency density. So 8 divided by 20 is 0.4. 48 divided by 20, 2.4. 44 divided by 40, 1.1. 10 divided by 40 is 0.25. And 0.25. Okay, so now I've got all the information I need to draw my chart. So my first bar is going to be from 80 to 100, and it's going to have a height of 0.4. So I've not been given a scale for frequency density up the side here. So the first thing to do really is then decide what the increments are going to be up this scale. So I've got to go up to 2.4. That's my largest value. So that's going to have to be at the top of my scale. Counting up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. So, and I want to go up to 2.4. So if I go 2 squares, so 1 square is, so if I take one little square, oops, if I take one little square is 0.2, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4. That seems to fit in nicely. Okay, so my first bar was frequency density of 0.4 and going from 80 to 100. Okay, now the second bar goes from 100 to 120 and has a height of 2.4. Okay, now the next bar goes from 120 to 160 with a height of 1.1. So notice that one is a bit wider than the other two because it represents a wider class width. The next one is running from 160 to 200, has a height of 0.25. And then finally, well, I've just noticed this one's wrong actually. That should be 10 divided by 100 is 0.1, isn't it? So correcting that, then 200 to 300 at a height of 0.1. So that completes my histogram. A shape is made up by joining a triangle ABC to a semicircle with diameter AC. Work out the total area of the shape. So what we're going to have to do, we're going to have to find the area of the semicircle and the area of the triangle and add them together. So the semicircle area is going to be fairly straightforward, you'd think, wouldn't you? Because the area of a circle is pi r squared over 2. So we need to work out what pi r squared over 2 is, but that means we need to know what r is, and we've not been given r. So we're going to have to work out what r is. So r is going to be half of this diameter here. So we're going to have to find the line AC. Okay. Now the other area, the area of the triangle, is going to be fairly straightforward because it's a non-right angle triangle where we know two sides and the included angle. So that one, that one's fairly straightforward actually. We can just use the trigonometric formula for area of a triangle, which is area equals a half AB sine C. Okay, we know everything in there, so we can work that one out, no problem at all. That's going to be a half times A, which is 8, times 10, which is 10, and times the sine of 114. So that's just tap it into the calculator and find out what the answer is. That's the easy squeezy bit. So half times 8 times 10 times the sine of 114. Okay, that comes out to be 36.5. I'm going to write an extra digit down because I'm going to round it off later. So I'm going to write down 4 digits and I'll drop down to 3 later. Okay. So that's that bit done. Now the next thing we need to do is know what AC is. So we want to find the third side of a non-right angle triangle. Given the fact we know the other two sides in an angle. This is clearly a job for our trigonometry and non-right angle triangle rules, but is it the sine rule or is it the cosine rule? The sine rule tells us about opposite pairs, and the cosine rule tells us about 3 sides. Okay, so this one is about 3 sides because we've got 2 sides, we want a third side, so it's going to be the cosine rule. So using cosine rule, which states that we want B, don't we? This is side B. We label up the sides opposite the angles. So this is going to be side A, and this is going to be side C. So we want B, and so the cosine rule says B squared equals to the other two things squared, A squared plus C squared, minus 2 lots of the other two things multiplied together, multiplied by the cosine of your angle. Okay, so that's what we're going to do. B squared equals A squared plus C squared minus 2AC cos B. Now, sub in. A is 10, 10 squared. C is 8, 8 squared, minus 2 lots of 10, lots of 8, times the cosine of 114. Okay, now I tried to do as much of this by hand first, because I think you're more likely going to make a key in area on your calculator with the complex thing than you are by squaring 10. You should all know that 10 squared is 100 and 8 squared is 64, and you should be able to multiply 2 times 10 times 8 in your head. That's 160. So just do the maths that you can in your head. That's easy to do, because it doesn't take very long, and like I say, you are more likely to make a key in area in a horrendous long calculation you have to type in your calculator than you are doing some basic maths, which, given that you're a top set, you're a higher tier student, you should be able to cope with. Right, so 164 minus 160 cos 115 then. So I've made it super easy for me to type that in, because I've done all the maths along the way and reduced it down as much as possible. That comes out to be 229 and change. Okay, but don't forget you need to square root that. It's the square root of 229 and change. I'm just going to write that down, but I'm going to square root my whole value. So square root answer 15.14. I'm going to write it down to 4 significant figures first, because we haven't quite finished. And then I'm going to say then, so that's my length B, and then, so now I know what AC is, which is the diameter. So then my radius is going to be half that then, isn't it? It's going to be divided by 2. So that's 7.568. 7.568. Okay, and now we can find the area of the semicircle then, can't we? So then the area of the semicircle is going to be pi lots of 568 squared over 2, which is equal to, so that thing squared divided by 2 and times by pi. I make that 89.96. So then I've got the area of the semicircle, got the area of the triangle, so then the total area is going to be those things added together. I feel like I'm on a roll. 89.96 plus 36.54. What's that then? Plus 36.54. Now I'm going to round it off to 3 significant figures. I was keeping it to 4 significant figures as I was going through, so that when I could drop down to 3, I'm not going to lose too much accuracy along the way. So 126 units squared centimeters. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.